Hello guys, and welcome to a very new tutorial on this series. In this tutorial we are going to start with TensorFlow and get the basic understanding of tensors. I hope you have seen my previous video on the introduction of tensors. If not, please go and check it out so that you can understand what exactly tensors are, and from this video we are going to code it. Okay, so let's start. I'll be using the editor VS Code. Feel free to use any other editor of your choice. It doesn't matter because it's the concept that counts, not the editor. Okay, so before starting, let's import some libraries. I import OS. It's basically for path and everything. And also TensorFlow, import TensorFlow as TF, and before that let's write so os.environ. What does this mean? I will show you in a couple of in just a while. Let's set it to 2. So this line actually helps preventing unnecessary message, unnecessary warnings and infos. And well, it's not that just writing by this line you will get all the warnings and info removed, but sometimes most of them actually gets removed. So, and depending on other variables, this may or may not work, but it's actually a habit for me to always use this line, so I hope it works. Alright, so now let's start creating some tensors. So I've created a main area, so this actually represents, so here the execution starts, right? Let's first of all see some devices. Either am I using a GPU or a CPU? How do I know that? So I can write device is equals to tf.config list physical devices, right? So tf.config.list physical devices, or maybe then not list physical devices, maybe we should go with list logical devices. What are physical devices and logical devices? I'll explain it in a while, but let's first of all print. Now this will show you all the devices that we have for this machine, in this machine, and then we'll get this particular idea of as in how it's working. Well, I guess this OS line didn't work and we are getting so many unnecessary infos, but no problem. Now here we see that we have a logical device CPU and another logical device GPU. In simple terms, logical devices and physical devices. So physical devices is actually your installed GPUs and CPUs that you have. Logical devices are the one where your operations will get performed, on which devices we actually perform our operations. So that's what the logical devices is about. But I guess that's it. I mean, we see that we have GPUs available, so we will use GPU for our case. But that's fine. We just wanted to check. Let's create some tensors, right? I'm very happy about creating some tensors. Let's create a tensor, tf.constant. So as the name represents, constant is simply a tensor which defines some constant values. So let's define some tensors. Let's say a rank 2 tensor, 1, 2, 3, 4. Similarly, let's say I take 4, 5, 6, 7. You can also define what is the data type. So let's say the data type is tf.float32. That means I want the numbers to be floating points, as well as the shape. I can simply define, I don't have to define the shape since it's already there. The TensorFlow will automatically figure out the shape, and we can print the tensor, we can print the tensor, what is the shape of the tensors, and we can also print that what are the types the data type. So D type, that represents these numbers, are they integers or floating points or whatever. So if we execute this, we should see these tensors, and we see that okay, we have tf.tensor, the shape is 2, 4, the shape, it's automatically there, but I've printed it separately to 4, and the data type float 32. So voila, you have created a very first tensor. Now let's do some cool stuff along with it. You can also generate some random numbers. How do we do that? Let's generate some random values, a Gaussian value. Now what is Gaussian distribution? Let's not go into that right now, we will explain as the course goes along with it, but let's assume that we know it right now, and we can simply create it as tf.random, as the name says, .normal. So normal means that it's a normal distribution. You can give it a shape of your like. Let's say I want a 2 cross 2, or maybe you can also create like this 2 cross 2 cross 2, or rank a 3 tensor, and you can also print it. We can also have, okay, so if I print the Gaussian, so we will see the Gaussian distribution. We can also do some cool stuff. So we have 2, 2, 2, that means we have total 8 elements. So I want to, let's say, flatten out. I just want to transform this 2, 2, 2 to 1 cross 8. It's possible. Why? Yes, one important point, it's very important that when you reshape, or if you suppose want to play around with your tensor, maybe change their shape, it's very important that these shapes must be compatible. Suppose if you have just 7 elements in your tensor and you want to get the shape 1 cross 8, it doesn't matter, right? Because it won't work, because there are no 8 elements, just 7 elements. So but here it's possible because I have since we have 8 elements and we are actually creating 8 values, so this is actually possible. Now how do I do that? Well, we can simply write print, I guess it's tf.reshape. Yes, tf.reshape. Let's try something. So we have Gaussian, and I can simply write -1. So -1 shape simply says that just flatten it out, or you can just give shape of your any choice. Let's give 8, 1, and let's print it, and let's see that, let's also add some /n/n/n, that will give us some proper line breaks so that we can see our output more easily. Now you see, so this was 2 cross 2 cross 2, 8 elements, and now I reshaped it to 8 cross 1. I can also do 1 cross 8. I can write simply 1, 8, or you can also write simply -1. So -1 also simply means that I just flatten it out. That means I just want a rank 1 tensor. A rank 1 tensor of just 8 elements, right? So that's good. You have done, you did some quite simple play around with your tensors. We can also define another type of tensor. So this was constant tensor. So constant tensor is, as the name simplifies, that you cannot change its values. We have also called as a variable tensor. Now variable tensor are mostly used in, of course, machine and deep learning. Constant tensors are also used there. So constant tensors, you will create it as the input, because we won't be changing input unless you are doing adversarial training, but we won't be doing it right now. So that's why we define our input as constants. So but in machine learning and deep learning, we will also do something called as gradient computation. What is this? We will talk this later. So for this, we want a tensor in which we can also change our values. So we can have a variable tensor. Let's say tf. Variable. It's exactly same as how you define your tf.constants. So you give their initial values as some tensor. Let's say I define just 1, 2, 3, 4, 5, right? It's fine. I can write trainable is true or false. Now what is trainable? Trainable means that it can, trainable simply says that this variable would take part in the training of the model and its value might change. That's it. Just let's keep it there that way. And we can also define the data type, tf.float 32. There are several options. tf.float 16, 32. You can also go with int 16, 32, but we mostly take float values. But yeah, you got the idea, right? So we can also print it, and let's see that whether this works or not, or maybe we get an error. I don't know. We know how this works by actually executing it. So we get a variable tensor, rank 1 tensor of 4 values. It's as simple as that. Now you can change the values of this by, there are several values. For example, you can also write variable.assign. So assign simply means simply assign this variable to something different value. Maybe we can give let's say okay, let's assign to this something value 1 2 3 4. Let's see whether this will work or not. I don't know, I'm just kind of feeling bit. Let's see whether it works or not. I guess it worked. Okay, so I actually give the same tensor. So let's say 1 2. I mean, so I just wrote variable.assign. That means just assign the entire variable. But I guess shape mismatch. The variable shape 4 and the value 2 should be compatible. Okay. So this basically means that I cannot give various different values. That means if I have 4 elements, I need to give 4 values. Let's try this. Maybe this will work or not. I don't know. But I guess it worked. So that basically means that you can assign variable to different value, but the shape must be compatible. Okay, I can also do something like this. I guess I can also write this variable of 0. So variable of 0 means just taking this first element and just I want to change this first element to 5. Can I do that? Let's see. I hope I should be able to do that. If not, yeah, I am able to do that. I can also change maybe variable just 0:2 dot assign. I don't know, it's very, so 0, 1, that means just 2 values. Let's say 8, 9. I don't know, it seems very good. Yeah. I guess it worked. So first of all, this 1 got changed to 5, and then 0:2, that means 0, 1. So the first 2 values got changed to 8, 9. So I guess we are good. So that's how you can change the variables. You can also do something like this. Maybe instead of this assign, you can do assign underscore add. So assign underscore add simply means that whatever variable 0 is, that is 1, simply add 5 in it, right? Simply add 5 in it, and then I guess we are fine, right? Do I have to define like this or this? But I don't know. Let's, trying is always the best way, because you get errors, and if you get errors, you know how to debug it. So it's very good. Okay, eager tensor. Okay, I got it. So there are 2 different values. There is something called as an eager tensor, and where you cannot actually do these operations, assign, add, or assign. What are eager tensors? There are different mode of executions in TensorFlow. We will come to that later, but I guess this we cannot do. It's as simple as that. Let's do something like this. Let me also explain why we cannot do this, because this entire variable value was a variable, but this is one value in itself. It's not a variable, it's actually sort of constant. That's why we were not able to do that. I guess, maybe I'm also sure. I should not say maybe, because it doesn't make me sound confident, right? I can also add, let's say if this entire thing is a variable, that means I can at least do this. If I want to add this entire tensor with another tensor of the same dimension, this will work, because this variable in itself is a variable tensor, and I'm adding to another same dimension, so it's possible, and I am right, it's possible. I cannot do just one element because that one element in itself is not a variable, it's a constant. That's why we got the error of eager tensor, but we are fine. Okay, so we can also do tf dot sub, that represents subtracting, but you got the idea. Okay, now let's also do some what do? We can also do some different values, so different things. So we saw Gaussian, we can also get some other distribution like what should I do? Maybe we can also start with doing some uniform distribution, or yes, so uniform distribution, it's like just random values between some range. Yeah, so if I say uniform, I can simply tf dot random dot uniform, and then I give him the shape. The shape should be, let's say, 2 comma 2, and I want that the minimum value should be just 0 and the maximum value it can take, max value it can take is 1, and the data type should be, let's say, tf dot int64. Let's just take 2 because I think that the 2 will not be included, it's either 0 comma 1. So 2 is actually an open bound, so that means 2 won't be included there if I'm right, because most of the cases I'm right, but also I'm wrong sometimes, but it's fine to be wrong as long as you learn from your lessons. Let's see. Ooh, but yeah, I'm right, because what it did, it actually took all the values as zeros. Let me create some big values. 10, 10, let's say 10 cross 10 matrix. What do I get? Yes, exactly, I'm right. That's a 0, 1 matrix. So you can also create matrices like this. It's a uniform distribution, so it kind of did good. Now we also have different things that you can do, like we can create zeros value like tf dot zeros, and you can also give some shape as 2 comma 2, so it will create zeros of 2 comma 2 matrix. Similarly tf dot ones and etc. So these are like basic operations that you can do. Some of important things that we can do, or some of, yeah, one very important point that I just got in mind. Suppose I have two tensors, right? Let's say I define one tensor as tensor 1 tf dot constant, and I just said I don't know, maybe just taking just one value, that is a rank 0 tensor, like I told you in the very first lesson. I hope you have taken it. And I define as data type as tf dot float 32. I take tensor 2 and I do tf dot constant value as 1, and let's say data type as tf dot int 64, or you can take any other values as well. We can just, let's say, add to see what we get the values, right? Let's see, what do we get the value here? Exactly. And it's a very important point that you remember here. I mean, it's a very simple operation. There is one float, one integer, and when we add it, we should actually get 2. But the thing is, TensorFlow does not allow two tensors of different data types to be performed together. I know it's quite very like, why? Can't a TensorFlow automatically convert one to another? Of course it can, but just imagine the case where you are doing something very complicated and so because different very complicated, and just because of the things are in different data types, you might get some rounding errors or some values that you can't figure out on, and you are just waiting around along with your coffee thinking, what's wrong with my life? Why not things are going my way? That's why TensorFlow said that let's make things easy. So I will just generate an error if there are different data types, so that you don't have to deal with rounding errors and some other calculative errors. So that's why you need to convert. So what you can do, so you can write tensor2 as, let's say, tf dot cast right? Tensor 2, and let's say I want to convert this to tf.float 32. Now we can add it, because now they are both in a same shape, sorry, same data type, so we can add it and then we get 2. So we can also there is also like maybe I guess tf.add, tf.math.add or tf.add, both are same thing. You can also like give tensor 1, tensor 2, so to actually get the operation, right? The same thing. Similarly, you can plus, minus, divide, multiply, it's your choice. Let's say print tf dot divide tensor 1 with tensor 2, or you can also just write the symbol, it's your choice. You can also do print tf dot divide, sorry, not divide, let's say, what's it, multiply, yes, and tensor 1, tensor 2, tensor 1, tensor 2. You can also, let's say, print tensor 1 minus tensor 2, which seems pretty reasonable. And so we also have the operations like plus, divide, so you get the idea, right? Okay, so I guess this was small things. Let me see what different things I also wanted to, yes, one very important operation. Let's define another tensor. Yeah, so let's say define a tensor. Let's say tf.random.uniform. I want to define a tensor of the shape. Let's say I wanted to get 1 cross 8, right? And min, well, let's say 0, max, well, let's say 2, and the data type should be tf.int 32. Right, now if I print the tensor, right, let's see what we get. I mean, of course you have seen this already, you know what we will get, but now we get these values, and it's a 1,8. That means it's like a rank 1 tensor. But if you see, so actually it's a rank 2 tensor. But if you see, shouldn't it be like rank 1 tensor, because we have just like some values? But the thing is, these brackets actually add one dimension. So if suppose I want to just get from 1,8 to just 8 values, how can I do that? I can reduce the dimension. So I can squeeze the dimension, let's say tf dot squeeze, yes, and I say tensor, now the axis. Now if you remember my lecture of the axis part, I've showed you how axis work. Now what axis should I give? Should I give 0 or 1? Well, I know that I want to squeeze the first dimension, so if I know, I said that whatever axis that I give, I'm just trying to squeeze it up, or I'm just trying to remove it up. So I should give axis 0 because I want to squeeze the first dimension. Right, now I can print a squeeze, and let's see. See, now we get just a rank 1 tensor. You can also increase the dimension. So you can, suppose I want 1,8, 1, right? Just adding one more dimension. So tf.expand dimension, I give tensor, and along which axis you want to do. Well, I just want to add it on the last time, so just give -1 or 0, 1, 2, because 2 is the last dimension. So if I execute it, well, probably not a good name, but now you see how just adding one dimension actually changed the form of a tensor. So it's very important that you know how to play around with these things, because these things will actually give you some proper ideas in how things goes. Okay, let's do also some quite good things from here. All right, let's define a tensor something like this, so that we can understand this axis thing much more properly. tf.constant, and I give, let's say 1, 2, 3, and I give 4, 5, 6, right? And I give d type as tf.float 32. Now if I say print tf dot reduce underscore mean, now there is mean, there is max, there is min, there is sum. It's just like mean, sum, just there is a reduce word in terms of it. Why it's reduced? Because it's, you can imagine it as they are GPU enhanced or something like that. Yeah, so that's why there is reduce term. So I want to take out the mean of this tensor. Now you might ask, along which axis I want to take the mean. Now I give 0. 0 means the first dimension. So just take a second and tell me what should be the dimension of the output and how many numbers will I get and why will I get it. Okay, I guess you have paused the video and checked it. Let's run it. Now axis is 0. I got 3 values, and which kind of makes sense because I said it's 2 cross 3, so it's axis 0, that means I'm reducing the first dimension, so it would become 1 cross 3. So I have 3 elements. Where am I getting 3 elements? Column wise, so simply take the mean column wise. Right, you can also calculate it row wise by adding it to 1. So you get the idea. Similarly, we have reduce max, reduce, you can also calculate the max along the axis, or similarly, right? Now let's make it much more interesting. If I take a tensor, let's say tf.random.uniform, I take a shape of 2, 2, 2, right? And the min well is 0, the max well is 2, the data type is tf.int32. Now I want to calculate print tf.reduce sum. I give the tensor and I give the axis as -1. Now what would I get the answer? Pause it, think about it properly, and then let me know. Well, why let me know? Because I'm going to just give you the answer, but just try. I guess you did it. Now if I run it, we get 2, 2. I guess now you know why 2, 2. It's because I said it's axis negative, but that means I'm trying to reduce the last axis. So 2, 2, 2 should become 2, 2, 1 or 2, 2. Now it's just taking the sum channel wise, pixel wise, because if you remember the first lesson, I showed you that one pixel has 3 values, one for red, one for green, one for blue, right? So that means it's just to take per pixel, it's simply just adding all the 3 values per pixel. So it just, this one is nothing but adding the green value of first pixel plus green value of adding the red value of first pixel plus adding the green value of first pixel plus adding the blue value of first pixel, and then I got 1. So that's how actually it works. So I guess the axis part is now much more clear. So these basic operations you can do with tensors, and you can also do some complicated stuff with it as well. Let's see what different things I should teach you in this lesson. Yes, let me also tell you how you can do matrix multiplication, which is kind of a simple thing. Okay, so let's define 2 tensors. Okay, let's tensor 1 as tf.constant. Let me just do 1, 2, 3, 4, 5, 6. Yeah, and I take tensor 2. tf.constant. I also take 6 elements. Yeah, 1, 2. Sorry. Yeah, let's take the same thing. 3, 4, 5, and 6. Now let's reshape it. Yeah, so tensor 1 tf.reshape. I take tensor 1. Now I give it the shape. Now I have 6 elements, so I can do 3, 2, right? Of course I can do that. tensor 2, always remember that the shape should be compatible or else you'll get the error. Shape, let's give 2, 3 and let's multiply them together. There are two different ways. The proper way, the simplest, I mean not the simplest, the standard way that you would do is tf.matmul. You will give tensor 1 and then we need to transpose the tensor 2, right? Or should I not? Well, if you think about it here in proper sense, we have tensor 1 and tensor 2. So let's just do tensor 2. Just I want to multiply these two things. Will I get the result? Well, of course, because the shape is there, 3, 2, 2, 3. Should I do tf.transpose? Will I get the result? Well, I guess not. Why not? I hope you know it. Why not? Because the shape is not matching, or the shape doesn't match. If this was 3, 2, then we would have gotten a very beautiful result like earlier before, the same result. Yeah. Now let's see some of the other operations before we conclude this first lecture. Sorry, this another lecture. We can also have the range values. That means you can also define like tf.range like 0, 10, and you can get the range values. So in this lesson we are just playing around with different functions. You have to get a basic understanding of the TensorFlow range values, and let's print it. Let's see what error or values we get. Well, not error, just the value 0 to 9, and it kind of makes sense. So I guess that's it. In this lesson we just talked about the basic fundamentals of TensorFlow, how to create tensors, how to play around with it, how to reshape it, how to change the type of tensor from one thing to another thing, how to create some distribution tensor like normal, how to reshape the tensor, how to play with axes and these things. So I guess you got the basic fundamental idea, and for this video this is it. And now I will see you in the next video, and please subscribe my channel, like my video, share it with your friends so that you also stay updated in this journey. Until next time, Radhe Radhe.